The topic is mixed operations with fractions, decimals, and integers. The essential question says, can you apply what you know about equivalence and your number sense to simplify expressions and solve equations? So something that you need to know is adding, subtracting, multiplying, and dividing fractions and decimals is just like everything you've learned about performing those same operations with integers. The same rules apply. So here's some examples. Now I want to kind of explain this chart here and how I've color-coded it. This first column right here, these are all operations, adding, subtracting, multiplying, dividing, with integers. Remember, an integer is any whole number and its opposite, and 0 is an integer too. The second column right here, you see that they're all operations having to do with fractions. And the third column has operations all that involve decimals, okay? And then next way that I color-coded this is going across by the rows. So this first row right here, you'll see that it's got additive inverses with integers, additive inverses with fractions, and additive inverses in decimals. And then the next row, positive times a negative, all that has to do with that operation. Modeling on a number line, you'll see it's all right here. Absolute values, all three of those again involve absolute values, and then negative divided by negative. These all right here are where you're subtracting a negative. Right here is where you're adding a negative. Okay? And the whole point of me doing this table is because I want you to see that the same rules apply. Just like I've taught you with integers, it's going to be the same as with fractions and decimals. So I don't want you to be intimidated by them. Okay? So let's go ahead and get started, and I want to show you how additive inverses within integers will be similar to what you would do with fractions and with decimals. So an additive inverse is, there are two numbers that are opposites of each other. So when I have negative 5 plus 5, your answer would be 0, okay? Think of where you're at on the number line. You're 5 to the left of 0. And then when you add 5 to it, you'd move 5 to the right from this negative 5, placing you at 0, okay? Well, right here you see you also have additive inverses, opposites. You have a positive 3/8 right there and a negative 3/8 right there, and you're adding them together. Your solution would also be 0. Because right here, you'd be 3/8 to the right of 0 on a number line, because it's a positive 3/8, and then you're going to move 3/8 units back to the left from this 3/8, placing you at 0, okay? And again right here, negative 1/10 plus 1/10, that's going to give you 0. All right, positive times a negative. So remember this old thing like this? This only works for multiplication and division. So when you build this little tic-tac-toe chart, you want positives going diagonally down to the right. Everything else make it negative. And this only works for multiplication. Multiplication is used this way, and then division would be used as the columns, okay? So again, it's only for multiplication and division. No adding and subtracting, okay? All right, so a positive times a negative. So a positive times a negative would give me a negative solution, okay? Oh, I see parentheses here, so you gotta multiply. 4 times a negative 2. That gives you a negative 8, because a positive times a negative is a negative answer. Okay? Right here, again, you see a number right outside parentheses. You got to multiply. So I'm drawing the arrow just to remind myself, hey, multiply, okay? And I got fractions here. And the thing I like about multiplying fractions is that I just go straight across. So you'll see 1 times a negative 3, which would give me a negative 3. Then I got 2 times, that's a positive 4. 2 times 4 is 8. Okay, so my solution to 1/2 times negative 3/4 is negative 3/8. Now I would think to myself, gosh, does negative 3/8 simplify as a fraction further? Nope, so that's its simplified form. So that's my answer. Okay, right here. Oh, look, it's a positive times a negative, so I know my answer is going to be negative, so I'm going to already put that over there. So I have 2/10 times negative 7/10. And that would give me a negative 14/100. Okay, sorry, that negative should be moved to a little bit more to the left. say the same rules apply. A positive times a negative gives you a negative answer. Okay, the next row has to do with modeling on a number line, okay? So again, we're going to use vectors. We're going to start at 0. So there's my start of my vector. And it says if there's a positive 5. So since it's a positive 5, I'm going to go to the right 5 units. And in my vector there, so 1, 2, 3, 4, 5 would be right there. Okay, I'm going to draw my line as best as I can. Okay, plus a negative 4. Okay, so, oh look, you have a symbol directly outside parentheses, so a positive times a negative 4 is really a negative 4. So in reality, this is really like 5 minus 4. So I'm to the right 5. Now I got to go to the left 4 units from that 5. So 1, 2, 3, 4. That'd place me at a positive 1. So my answer is 1. Okay? Okay, right here. Look, I got parentheses. I have a number right outside parentheses. I mean a symbol directly outside parentheses. So I'm going to multiply. A positive times a negative gives me a negative. So really this problem is saying 3/4, whereas negative minus 1/4. Okay? And let's see what that will give me. Okay, I'm going to start at 0. It's a positive 3/4, so I'm going to go to the right to 3/4. Draw my vector. Now I have to go to the left because that's a minus 1/4. Just 1/4 of a unit. So since I'm counting by 1/4, I would just go over 1 to right there. And I would get 2/4 as my answer. But what's even better is that simplifies. And I like simplified answers. So let's keep it as fraction. So divide by 2, divide by 2. This divided by 2, and this divided by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So 1/2. If you wrote down 2/4, I wouldn't be mad about that at all because they're equal to each other. Okay, the next column, negative 3/10 plus 5/10. So with vectors, start at 0, and it says negative 3/10. So I'm going to go to the right 3/10. So there's 1/10, 2/10, 3/10. There's my vector. And now it says plus 5/10. So I need to go to the right from this spot to the right 5/10. Okay? So there's my start of my vector. There's 1/10, 2/10, 3/10, 4/10, 5/10. And it ends right there, right at 2/10 as my answer. Oops, if I can write it. Okay? See how you model it on a number line just like you would it with dealing with integers. So please don't be intimidated by those fractions and decimals. It's the same exact process. Okay, absolute values. You should know that this symbol right here means absolute value. And what absolute value means is, hey, how far is that from 0? What's the distance that is from 0? Okay? So you know distance is always positive. All right, so I'm going to kind of ignore all that right now. I have negative 6 minus 3. I would be 6 units to the left of 0 on a number line. I'd go further to the left 3 more units, placing me at negative 9. So this is really saying absolute value of negative 9. What's that? How far away is negative 9 from 0? How many units is it away? Well, it's 9 units away. So the absolute value of this quantity right here is 9. Okay, don't freak out just because there's fractions. Go ahead and do this. We already got common denominators right here. So when it's a common denominator, we can just go ahead and subtract the numerators. 4 minus 6, well, 4 units to the right of 0. Okay, I'm picturing that in my head. Now I have to go to the left from that 4, 6 units. Well, that places me at negative 2. And remember, you want to keep the same denominator. So negative 2/5. That is a fraction, negative 2/5, and you want absolute value of that. So it's asking, hey, how far away is negative 2/5 from 0? Well, it's 2/5 units away. Okay? Now the one that involves decimals, same exact situation. We have 8/10. So you're to the right of 0, 8/10. And then you got to go to the left from that 8/10. 9/10. So you got to go and then go back, and you end up at negative 1/10. So we're looking for the absolute value of negative 1/10. Okay? How far away is negative 1/10 from 0? What's the distance? It's just 1/10 of a unit away. The next row is a negative divided by a negative. So just to kind of refresh your memories, we have this chart right here. And again, it only works for multiplication and division. Multiplication goes across using the rows. Division goes down, okay? That's how you read this chart. It's only for multiplication and division, nothing else, not addition and subtraction, heck no, okay? So anyway, we got a negative divided by negative. So let's see what column that is. Not this one, because that's positive divided by negative gives me a negative. Negative divided by positive gives me a negative answer. So here, negative divided by negative will give me a positive answer. Okay, so all these are going to be, when it's a negative divided by negative, we'll have a positive answer. Okay, so let's go ahead and simplify this fraction. So think of a number that goes into both 100 and 200. And the biggest number that I can think of that goes into both like equally is 100. So I'm going to divide the numerator by 100, the denominator by 100. Okay, and negative 100 divided by 100 is negative 1. Negative 200 divided by a positive 100 is a negative 2. And negative 1 half, negative 1 over negative 2 will also equal a positive 1 over 2, okay? Because remember, a negative divided by a negative gives you a positive, so here's my positive solution. So I have 1 half. Okay, oh, look what we have here. We've got a negative divided by a negative, but we have fractions. And the thing you got to remember when you're dividing by a fraction is that keep, change, flip thing that that I'm sure you've gone over before, okay? So here's what we would do. I'm gonna write it kind of small. I hope you can see it. Negative 2/3, so I'm gonna keep that. Now change this to multiplication, and I'm gonna flip this. So I need the reciprocal of a negative 1 half, and that would be positive 2 over negative 1, okay? So now, just like I love about multiplying with fractions, you just go straight across. Negative 2 times 2, well, a negative times a positive gives me a negative. So negative 2 times positive 2 is a negative 4. And then 3 times a negative 1, positive times a negative gives me a negative. 3 times negative 1 is negative 3. So we would also have 4/3, positive 4/3. Okay? Another way you can write that, because you'll see that's an improper fraction, you can also write it as 1 and 1/3. Okay? Because 3 fits into 4 one time, keep your same denominator, and 3 times 1 is 3, plus 1 more would give me that 4/3, that 4, okay? So 4/3 and 1 and 1/3 are the exact same thing. So those are both cool as your answer. Okay, right here, we have negative 6/10 divided by negative 3/10. So basically I'm like, okay, 6 divided by 3, that's 2. So 6/10 divided by 3/10 would be 2/10, okay? And the reason I didn't mention anything about the negatives is because I already know negative divided by negative is a positive. So I'm kind of like thinking, okay, 0.6 divided by 0.3 is 0.2. Because I know the answer will be positive because a negative divided by a negative gives you a positive answer, okay? So you'll see all these answers right here in this row are positive. Okay, subtracting a negative is our next row. And look, we have parentheses, and I see that there's a symbol directly outside those parentheses. So a negative times a negative is a positive. So a negative times a negative 4 will be a positive 4. So in reality, this is really 9 plus 4. I mean, oh, I don't know why I wrote a 5. I'm so sorry. Okay. 9 plus 4. There we go, teacher. Okay, 9 plus 4, that gives me 13. Okay. And look right here, we got a negative times a negative, which a negative times a negative is a positive, so this is really 1/4 plus 3/4, okay? And when I'm looking at that, I see that we have common denominators already, so I don't have to do any adjusting of those fractions to make them the same size pieces because they're already the same size. So now I'm just going to go 1 plus 3, that's 4. Keep that same denominator because when you're adding or subtracting fractions, you want to keep the same denominator. And that's why we want them to be the same denominator because you keep them the same. And well, look, 4 divided by 4, that's 1. Okay? All right, right here again, I have parentheses. I see that there's a symbol directly outside of it, so I got to multiply. So a negative times a negative 5/10 would be a positive 5/10. So this is really 3/10 plus 5/10. Well, 3/10 plus 5/10, that's 8/10. Okay? So don't forget, when you have parentheses and you have a symbol or a number directly in front of those parentheses, you want to multiply that symbol or that number by everything inside the parentheses. All right, we're adding negatives now, okay? So we're adding a negative value, adding a negative value, adding a negative value. And look, you see that there are parentheses. So I have a positive times a negative. Well, what's a positive times a negative? Positive times a negative gives you a negative answer, okay? So it's really positive times a negative 7 would give me negative 7. So really this problem is negative 4 minus 7. And think of where you're at on the number line. You're 4 to the left of 0. Then you're going to go to the left 7 more units, placing you at a negative 11. Okay? All right. Oh, look, parentheses again. Positive times a negative, that gives you a negative. So this problem is really negative 2/3 minus 4/3. And I've got the same denominators already, so we're good to go. So negative 2 minus 4 is negative 6, so this is negative 6/3. What's negative 6 divided by 3? Well, that's negative 2. Okay? Both of those are equal, so both of those are right, but this is more simplified. That third example involving decimals. A positive times a negative gives you a negative, so I'm going to go ahead and rewrite this problem as negative 5/10 minus 2/10. And I'm to the left 5/10, 0.5 to the left of 0. And then I got to go further to the left, 2/10 more, making me land at negative 7/10. Okay? So something that I want you to know is that, I want you to know the same rules apply. Don't be afraid of fractions and decimals, okay? We've gone over all this. We're starting all this stuff right here, and just don't be afraid because the same exact rules apply, okay? So your job for the summary, I want you to choose 5 of the most challenging problems from above, so any 5 of these over here, okay? And rewrite them, so rewrite the ones that you see, and then I want you to solve them. Show your work, okay? Please don't just sit there and just be like, oh, I'm just gonna copy everything. So if this was one of the challenging problems, write that down here, and then solve it, and then double check, well, did I get it right? And if you didn't, you want to keep practicing it, okay? Pick 5, I want to see 5. When you're performing operations with integers, decimals, and fractions, don't be afraid to use your number sense to simplify the problems for you. So use what you know about numbers and equivalents to solve these equations. So in other words, if you're like, gosh, I don't like fractions, and you can convert it into a decimal that's not one of those crazy long, weird decimals, I want you just to go ahead and do that, okay? If you don't like the decimal and you know its equivalence as a fraction, then do that. Make it so it's easier for you and your number sense, okay? Use your number sense. So I'm seeing right here, well, this right here is a fraction, right here is a decimal. And I'm going to go ahead and convert this negative 3/4 into a decimal. So to do that, I would go negative 3 divided by 4, and that would equal negative 0.75, negative 75 hundredths. Well, and I see right here, as I rewrite this, I have negative 75 hundredths, so I'm to the left of 0, 75 hundredths, and I can go to the right 1 and 75 hundredths units from there, and that puts me at 1, okay? So this right here, negative 75 hundredths plus 1 and 75 hundredths, that's 1. And look, I see parentheses with a symbol, the minus symbol directly outside of it, so I'm going to go ahead and distribute. A negative times a negative 20 is going to give me a positive 20, okay? Because a negative times a negative gives me a positive, so this is really 1 plus 20, which that equals 21. So the solution to all this junk up here is just 21. The next problem says the negative absolute value of 4 plus 4 minus 1 1/2 minus a negative 5/10. So what I would probably start off by doing is, I would do this absolute value of 4 right there, and they want the negative value of it. So the absolute value of 4 is 4, but they want the negative version. Please remember, do not treat absolute value symbols as if they are the same as parentheses. So do not use the distributive property whenever you see absolute value, okay? You just literally go absolute value of 4, which means how far away is 4 from 0, and it's 4 units, so that's why I wrote the 4 right there. But since there's that negative right in front of there, you just bring that down, okay? All right, I'll put that plus 4 right here. Let's see, negative 1 and 1/2. I can also rewrite that as negative 1 and 5/10. Remember, 5/10 simplifies down to 1/2. See, I divided by 5, divided by 5. So 5/10 right here is the same as 1/2, okay? Oh, and right here I'm subtracting a negative. So negative times a negative is going to give me a positive. So negative times a negative 5/10 is a positive 5/10, okay? So from here, oh, look, you have additive inverses right here, 0 pairs. So negative 4 plus 4, that's 0, so that's gone. And all you're left with is negative 1 and 5/10. All you're left with is negative 1 and 5/10 plus 5/10. So I want you to get a visual of this. Think about it on a number line right up here. So you've got negative 1 and 5/10, which would be right there, okay? And do you remember how it said plus 5/10? So when you're adding 5/10, you're going to go to the right. And 5/10 is the same as 1/2, so we're going to go to the right 5/10, and that puts us at negative 1, okay? So this right there is negative 1. Number 3, 500 1/1000ths minus a negative 1 plus the absolute value of all this junk in there. So let's see, I'm going to go ahead and start with this stuff in here, I guess. I have a number directly outside parentheses, so that's a positive 5 times 2 is a positive 10 plus 3, and then that's just a negative 3 right there, but the absolute value of all of this, oh, I have a negative 3 and a positive 3. Those are additive inverses, so those are negative 3 plus 3, that's 0, so that's like gone, and that's gone. So all I have left is the absolute value of 10. Okay, and then I got a plus sign, bring down everything I see. Oh, look! It's parentheses with a symbol in front of it, so negative times a negative 1 is a positive 1. Okay, and then, hey, this simplifies. A number that goes into both 500 and 1,000 is 500, so I can divide by 500 to simplify this fraction. 500 divided by 500 is 1, 1,000 divided by 500 is 2, 1/2. So it's 1/2 plus 1, that's 1 1/2. And then plus the absolute value of 10. How far away is 10 from 0? It's 10 units, so plus 10. 1 1/2 plus 10, that gives me, well, 1 plus 10 is 11, plus 1/2. That's 11 1/2. I can write 11.5, I can write 11 1/2. Those are both acceptable, okay, because they're equivalent to each other. Number 4. Oh, look what I see right here. I see this negative 1/2 because it's attached to this negative, plus 1/2. Those are additive inverses, so those are gone. So I have negative 8 left, and then bring down my plus 3 and 75/100ths. Oh, look, parentheses, positive times a negative 1/4 is going to, positive times a negative is a negative, so negative 1/4, okay? This is a decimal, so I'm going to go ahead and make this into a decimal also. 1 divided by 4 is 0.25. So it's really negative 8 plus 3.75 minus 0.25. And when I do this, I see, oh, 75/100ths minus 25/100ths. That is 5/100ths. I mean, 50/100ths, sorry. So this turns into negative 8 plus 3.5. Okay, if you're like, what happened? 3.75 minus 0.25 gives me 3.5. That negative 8 is from right there, okay? So now I'm going to go ahead and go negative 8 plus 3, so I'm 8 to the left of 0. I got to go to the right 3, and that puts me at negative 5. But then I got to go to the right 0.5 more units, and that would place me at negative 4 5/10. So that's the answer to this whole situation up here. And again, I could write negative 4 1/2 also, because they're equal to each other. All right, this one, you'll see that there's a missing numerator right here. So I know within the definition of equation, this whole side has to equal this whole side. Well, this is 5 2/100ths. You say it correctly, 5 and 2, and that's the 100th place, hundredths. Hey, look, there's a 5. There's a 5. So those match. So all that I need to find is this equivalent right here, 2/100ths. Hey, there's a 100ths. So this goes right there, that too. Okay? It really, really helps if you say this out loud correctly. Okay? 5 and 2/100ths. Oh, here's 5 and 2/100ths. Ta-da, how both sides are equal to each other now. So that's how I know that missing part of that equation is 2. Okay, let's do this again. Let's say it out loud. So that's a 4, that's a something tenths. And let's say this guy out loud correctly. 4 and say the 2 and then the tenths place. Okay, so I got a 4 right there. So something tenths. Oh, it's 2/10. Okay? For your summary, I want you to answer these two problems, number 7 and number 8. Please rewrite them and then figure out what goes here. This plus this, I'm not going to say it out loud because I want you to practice that, is equal to this plus this. So what the heck is that? Then this right here, I want you just to solve it. 1/3 minus 5 and 1/3 plus 2 plus 5/10 equals what? Okay.